Just keep checking, let people in. All right. Well, good morning. We're going to cover our last section for this chapter entitled Geometry Problems. As I suggested, it's really not a lot of geometry. It's really using the figures and formulas for things like perimeter and area and volume as reasons to use what we've been learning. That is plugging values into the formulas and then doing the calculation to come up with the value that we're looking for. Felt like a kind of a rough day for me yesterday, and I apologize. We made it through. I see most of you have gotten through a lot of that homework, 1.9 anyway, but especially if we have time, certainly glad to go over any questions you might have about that material. And of course, tomorrow is scheduled as our review day. Bring all your questions. I really encourage you to start the review assignments. They're not graded. We're kind of towards your overall grade, but they're sample questions, just like you'll see on the test. They're similar to homework questions. So I encourage you to get started on that. At least the mom review, and then there's a second one that's a worksheet. You could print that out if you wanted to just practice some more. But I encourage you to, at least glance through and give some of those a tries. Like, I really need to practice this kind. I know how to do that, or something like that. But bring your questions, right, for tomorrow. All right. So with that, here we go. So similar to the conversions section, if you go into the mom homework for this geometry section, up near the top of that page, there should be a link to a formula sheet. Again, if you've got access one way or another to different formulas for things like volume and area of these different geometric shapes, the formula should be the same. You're welcome to use them, but there is that form in mom. I know it doesn't help much for me to hold this up. It kind of looks like this, and it's got these basic shapes and the formulas that go along with them. And the mom doesn't, problems don't necessarily give you the formula in the problem. You need to be able to refer to that form to come up with the formula to use. All right, so we start with rectangles. Right. And this one you're going to see a lot. It comes up throughout the term in various situations, the shape, and then I guess the concept or the formulas we're going to use here. Let's see, get my stand out of the way a little bit here. Kind of a rough rectangle this morning. First concept that we talk about is perimeter. Basically, what is the distance around? If you were going to fence in this enclosure, or put trim around the floor of your rectangular room. So the perimeter is really just, we use P for perimeter, right, darker, okay. The perimeter is just the sum of all the sides, whether it's a rectangle, triangle, whatever. Usually we consider, say, let's call that the length and this the width. So the formula for the perimeter would be two of these dimensions, right? This length plus that length and two of those dimensions. So we usually write that like this. 2 lengths plus 2 widths is your perimeter. And so in this section, we're going to be given values. Sometimes you got to do a little work to figure them out. We'll just look at that in a second. But let's say, let's call this, say, 12 feet, and I'll call this one 9 feet. So what is the perimeter of this rectangle? So simply plugging these values in. Twice the length, twice the width, and multiply it out, add them together, squeeze it in here, right? 24 plus 18. I think that gets me to what, 42? And this is like an application. It's got units, right? This is just adding straight line lengths together. So we started in feet, we're going to end up in feet. Throw this out here right away. Be careful, read problems carefully. Sometimes they mix units together, like feet and inches or something like that. You have to have the same kind of units to be able to put them together, right? So there's a basic perimeter problem, right? Add up all the side lengths. You need the right information. You need enough information in order to do that. All right. And let's see. We'll see a couple that look, what is he doing here? Let's make up something that looks kind of like this. And let's say, oh, I know this is 10 inches, and I know this is 14 inches. And let's make this one 4, and this one 3. Find the perimeter of that figure. This 10 is not coming through real strong yet, but hopefully good enough. Well, hopefully you can reason it out. It's like, oh, what are these two other lengths here? I don't know. There's a couple of ways to think about it. One is, if it's rectangular, you might say, right? I know this is 14, and this part of it's 3. What's left over here, right? This must be 11. Hopefully that makes sense, huh? If this is 10, and this part of it over here is 4, what's left up here? This must be 6. So you have to figure that out a little bit for yourself. Now you can add all those sides together, and we still come up with, well, a perimeter by adding them all together. Now here's an interesting thing about this kind of shape. Think of this like originally a rectangle that you kind of punched in, right? This 11 would be the same up here as 11, and this 6 would be the same as if it was really a rectangle. It really is still just twice the 10 and twice the 14, right? There's just sort of a trick for that. But find the side lengths and add them all up, and you find your perimeter. All right. Go back to the basic rectangle shape again. Concept, well, so I mentioned already, perimeter is just a length, one dimension.
So sorry, you didn't finish that problem though. Where if I'm very confused by geometry. So inevitably, are you saying that if I were to add up, what would have been on that problem originally, the 10, the 4, the 14, the 11, the 6, and the 3, I'm going to get the perimeter of the object?
Yes. Okay, there. I'm sorry.
Sorry, this is the most confusing subject for me since fractions.
Thank you for jumping in and backing me up. If I assumed that made sense, and it doesn't necessarily.
You're quiet again.
Yeah. So yes, if I would have just added, you need every side length, right? Some of them might look like they're missing to begin with, and so you have to figure them out. Like I suggested, 10 minus 4 means this is 6. So you need all the lengths. You can't just add the numbers they tell you. You've got to make sure there's a number for every side, and then you add all the sides together.
So inevitably, there may be problems where we may not get that number right. We just kind of have to guess. I mean, there's just no foolproof way of knowing that this is what that missing number is going to be, other than us just using our intuition or recognizing that some of these sides are slightly bigger than the others.
It really was just a subtraction problem. Here, for instance, this side right here, when I first drew it, I didn't put a number in there.
Yeah.
So here, this width, let's call it, is a 10. Well, here's part of it. Okay, so this must be 10 minus 4.
Okay.
And this one was 14, and here was the part I gave you. So this was missing.
Okay. So you're kind of able to use what's given in the problem to kind of put that math together. Okay. Thank you very much for backing that up. Appreciate it.
Guessing that you shouldn't need to guess. There should be a way to figure it out. Okay.
Well, that's what I'm always hoping for.
Good. All right. Now I'm going to go on because now you could just add all those up. Hopefully. Yeah. All right. Back to rectangle again, full rectangle, and the concept is area. What's the floor space, right? And area is, we're assuming there's little squares. How many of those square units fill in that space? And so it's how many in this direction times how many in that direction makes how many total squares, or length times width. There's your basic rectangular area formula. So again, here we need to know what those dimensions are in order to do that. Let's say this was 8 feet, you know, that little single dash for feet and double dash for inches. And let's call this length, say 12 feet. So what's the area? And the area then, according to this formula, plug them in, 12 times 8 is 96. And kind of like opposite of yesterday where we were doing those conversions and I said, oh, you can cancel just like a common factor in the fraction, right? You cancel out the old units so you get the new units. Here we're really multiplying feet times feet as units. So we get square feet or feet squared. You can write feet squared or square feet. You can actually write it out. I think Mom is being pretty nice to you. When I looked at the homework problems, there were lots of units already there. You know, fill in the blank with the number and they have told you to the units. Kind of wish they didn't do that so much because we want you to recognize that area is always square units. Volume, when we get there, is always cubed, three-dimensional units. That perimeter was just straight units, one-dimensional, you know, feet stays feet. All right, so there is the basics for a rectangular area. Multiply the length times the width. Okay. Well, can they make it a little trickier? Of course we can. Let's say we've got that weird shape again. All right. And what did I say? I said, this was 10. That's all feet for right now. And I said, that was 3. And this was 4. All right. What's the area of this, you know, shaded area there, right? What's that area? Well, I kind of need to break this into 2 parts. There's a couple ways to approach it, but, you know, I want to make 2 shapes out of it, 2 rectangles out of it, and do my area twice. That's one way to do this. So I made a small rectangle here and another rectangle here. And so now what are the dimensions of those 2 little rectangles? I still, especially up here, right? This isn't the full 10. This is only this part of this 10. It's the 10 minus the 4. So this one's only 3 times 6. For that one, right? So say that's area, I'll call it area 1, right? 3 times 6, that part of it is 18 square feet. Now this one, I had full 14, and I was told that 4, but it could have been something else. So this part of it is 14 times 4. 56. For the longer little piece on the bottom. So I had to cut it up into pieces that I could, you know, calculate and find the dimensions for, and then calculate them separately. And then I'm just going to add them up, right? Add those 2 together. And what do I get? Let's see, 5, 6, 7. 74 square feet. In those 2 pieces. So I still needed a length and a width for each of those that I sort of cut it into. Sort of the other way to do it would be to think of, well, what if it was a full rectangle like that, right? I could do 10 times 14, and then I'd have to subtract whatever that was, right? I'd have to subtract, what is that, 6 here, and we figured out that was 11. I'd have to subtract that. I'm getting sloppy, slow down, Steve. 4, and still 74, good, same number. It should be. But that, you know, so Depends on how you see it, right? Cut it into little pieces and add them together, or think of it as a big piece and subtract what is cut out of it, sort of, right? It's just different approaches depending on what comes to you. So area and perimeter are the two things we're going to primarily deal with for these rectangles. And the messier rectangle problems would be ones where you have to sort of cut out like this, and you got to figure out the missing dimensions. Here goes, okay? All right. And next, a triangle. All right, 3 sides. We tend to call the bottom, whatever it's sitting on, the base, B. And this perpendicular, that means that's kind of a right angle there, right? From the point down to that base, we call the height, B and H. Yeah, you can see those. All right. If we wanted to know the perimeter of a rectangle, excuse me, a triangle, we just got to be told all 3 sides. We're not going to have means of calculating a missing side right now. I'm not going to, so perimeter is not going to come up, but area is. So the formula for the area of a triangle, any triangle, is 1/2 the base times the height. Right, 1/2 the base times the height. And so then we need those values. And really not too many ways around it, but they can get too tricky. Let's say this is 12 inches, and I'll say this is 7 inches. So what is the area of that triangle?
So really quick, is that the classic like problem for how do we figure out the area of a triangle specifically? Is that 1/2 times base times height?
Yes. And,
versus other shapes?
When like I referred to, you'll have to refer to a formula sheet if you don't happen to know that one off the top of your head, right? But if I look at triangle, there it is. Area is exactly that you're told that formula to use.
Do we have a formula sheet in our textbook?
And in the test problems, you tend to have, well, you could have it next to you while you take your test.
Where would I find one of those is what I'm asking. Can I just like Google it? Is it in the textbook? I don't know where I would find something like that.
If you go into the mom homework for this section, I think right at the top, it'll say there's a link to the geometric formulas page.
Okay, perfect. I start that today, so I wanted to ask. Thank you.
Yeah. Okay, so 1/2 times the base times the height and multiply. Whenever 1/2 times 12, I can say 6 times 7, and I'm going to get 42. Again, it's an area. Now it's a little harder to imagine with all the squares with the angles in there, but we still think of it as square units. So I made them all inches this time. So I would say inches squared or square inches this time. The area of that triangle. Applying the formula, you've got to have the right information. You plug in the numbers, and we're just doing the calculations right now. Okay. That one doesn't get tricky. I'm going to go on to the next. Okay, next shape. Just got to know the base and the height. We got to give you that. Circles. Hey, not bad. All right, and the distance around the circle, similar to perimeter, right? But for circle, the concept we call circumference. That's an M. Circumference. What's the distance around that circle? All right. We need a couple dimensions to use in our formula. All right. Diameter is the distance across the circle going through the center. That's the diameter. All right. And half of that, or from the center out to the edge, is the radius. That's our radius. All right. The radius is 1/2 the diameter, or the diameter is twice the radius. Those two make sense going opposite directions, right? Half of that diameter is the radius. Half the diameter is the radius, or twice the radius is the diameter. Depends on which direction you're thinking about it. So circumference is pi times the diameter. We'll talk about that in a second. Or because we know the diameter is twice the radius, they usually put the 2 first. 2 pi times the radius, because 2r is the same as the diameter. Two different versions of the formula for circumference of a circle. Just depending on whether you know the diameter. Like if I noticed in your mom problems, a lot of times they told you the diameter. And that works great for your circumference. We're going to do area in a minute. And that's always based on radius. So you may need to calculate, you may need to cut the diameter in half to find the radius sometimes. So again, we need these numbers. Oh, I just wanted to back up. I mentioned this briefly a day or two ago. Pi is actually defined, where did that number come from? As the ratio, or if I try to take the circumference and divide it by the diameter, how many diameters does it take to get all the way around a circle? A little more than 3 times. It's not exact. The Greeks didn't like that. They wanted everything to work out nice exactly. The universe is perfect in harmony. The numbers could always be whole numbers. They didn't like pi. But 3.14159 blah, blah, blah. That's basically where the number pi came from. It's, you know, calculated how many times does it take diameter to get around a circle. Okay, just a little side story there, right? So if I know the diameter is 15 inches, what's the circumference of this particular circle? Pi times 15. Now that's going to be a messy decimal. I looked at Mom, they were pretty good about telling you to round to the 10th place, 1 decimal. So when you pull out your calculator, got to use that, I assume. For the problems at this level, in terms of accuracy, if you're using that abbreviation, approximation 3.14, you're going to get close enough. But your calculators should, they all have a pi button. You could use that button. Right? Find that pi button on your calculator and just say, all right, pi times 15, and I've got 47.123, and my problem said round to tenths, so I'm going to stop right there. 47.12 rounded to 1. And what are my units? Inches. All right, so pi times the diameter. That's how far around it is. If you're told a radius, you're going to have to double that radius or use this version of the circumference formula. So 2 times the radius times pi to find that circumference. 3.14 should be good enough for you. But otherwise, you might get used to finding that pi button and using it. If that's good, I'm going to go to the area. All right. Not too tricky. Use pi times diameter. All right. Now the area is pi times the radius squared. Pi r squared. You've heard the dumb joke, right? Pi around. Anyway, you need the radius to find
Yes,
the
sir.
area.
Can I just interrupt you real quickly?
Yes.
I just wanted to jot this down. When you find, in order to find the circumference, when diameter is provided, it's pi times diameter.
Yes.
When radius is provided, to find circumference, it's pi times 2 times, what was that again?
Pi times 2 times the radius.
Okay,
Yes, and just, we usually put the number in front of things that look like variables. So you usually see it written like this, 2 pi r, rather than pi times 2r. But it's, you know, these two go together to make the diameter.
Roger that. Thank you.
Okay, good. But we need the radius if we're going to do the area. And kind of like the triangle, well, pi sort of helps take care of the fact that, gee, I can't really make it look like little squares all over, but it's still square units, square something. So let's say we've still got our 15-inch diameter here. What is my radius? Half of 15, right? Okay, so here, pi times, I'm going to call it 7.5 squared. Half of 15, 7.5, okay? Notice this square is just on that number, not pi. It's not multiply these two together and then square it. It's just the radius number that's getting squared. So there's a mistake that people make sometimes. I'm trying to point out. Don't do that. Now, your calculator is kind of nice. I can push my pi button times the 7.5, and then on most of your calculators, you actually have a x squared button. You could actually say pi times 7.5 and push the x squared, and it'll square that 7.5. Let's prove it. I'm going to do it. So here's pi times 7.5 times 7.5 the long way, and I got 176 point, I'll do 1 decimal point again, and this would be inches squared, square inches. And I'm just going to try this x squared button. Pi times 7.5 squared, yep. Same number, good. I was pretty sure that worked that way. Again, I like this little one. Way over here on the left side is where I have my pi button, and that x squared button is right there, just below it a couple steps. So it just squares the number that you just previously entered. That's kind of nice, convenient. Knowing how to be efficient with your calculator, that's all that is. So what did we do there? We found the area. Again, here's a formula. Yep, you see that on your formula sheet, formula for the area. You need the radius. If you had the diameter, you need to cut it in half yourself. Divide it by 2. That's what I did here. Then I did the calculation, came up with that area. All right. Good enough? All right. Again, I like to think that because you have this mold, this formula to work with, if you understand how it works, find the numbers. You can't do it if we don't give you the numbers, right? Find the numbers to work with and plug them in and then do the calculation. Okay. Now, let's see. I'm going to try a share here. Hang on, all right? Good luck, Steve. Chat 11:0. Oh, somebody's talking about formula sheets. Good. Good for you guys. All right, share your screen. And I'm going to go to the homework. All right. So just somebody give me a nod. Are you seeing what looks like the geometry homework page? Yes? I hope so.
I can.
Yes? Okay, good.
Yes, we can.
Say again?
Yes, we can.
Yes.
I'm sorry to be weird about that, but just making sure. Okay, so as I mentioned before, you know, all the mom problems are different for each of you. The numbers are different, but the same, the kind of problems are the same. Here's that link to that geometry formula sheet. Are you seeing that formula sheet? Yes, I hope.
Yes.
Yes.
So this is what you would pull up. We went over the triangle and we went over, where is it down there? The rectangle and the circle. Now here are a number of other shapes, you know, trapezoid, parallelogram, and then get even the square. You know, the square is a special version of a rectangle where the sides are all the same. And then some three-dimensional figures and we'll figure out volume. V for volume. Volume is cubic, like you put little cubes into that space. Rather than units squared, we'd have cubic feet or cubic inches or centimeters or something like that. And this SA, surface area. Now, I don't recall, there might be one problem where this is a formula for surface area, but it really can be broken down into, you know, what are all the different sides, and then add them together. Like, see, here's a circle on top and a circle on the bottom. So there's 2 times pi r squared, 2 times the area of a circle. And here's a formula. This is the formula for how far around. It's kind of like if you unwrap this thing, it'd be a rectangle. Does that make sense? If you took the sides of this cylinder, it'd be a rectangle where the length was the circumference. Anyway, here's formulas for surface area. We don't use those too much, but that's what that's all about. All right, I'm going to see if I can close that and go back. Let's go back to, yes. All right, I like to talk through these geometry homework problems a little bit, just scroll through and say, see, we just did this, or you can figure this out. Anyway, first one, find the perimeter of a rectangle measuring, mine says 5.7 centimeters by 12.7 centimeters. Draw yourself a sketch. I encourage you to do that and put in the figures if that helps. But there you have the length and width for a rectangle, and you're asked to calculate the perimeter and the area, right? That's where we started. Here then is a triangle, and you're given the base and you're given the height. Find the area of the triangle, just the way we started for that one. Here it gets a little more wordy, like word problem. Mine says Hillary has a sprinkler that covers a circular area with a diameter of 32 feet. What is the area of lawn the sprinkler covers? You've got a circle, draw a sketch if you want. You're told the diameter, and then you've got to calculate the area. So yes, you will have to come up with the radius to use the area formula. Here's one of those weird rectangle shapes, right? Got to figure out what side lengths are missing. You know, up there in the corner, just kind of like my sketch was. Let's see, 10 minus 2 means this long one must be 8, or 7 minus 4 means this short one must be 3 for my problem. Yours will have slightly different numbers in it, probably. Perimeter, and then area. Remember, we chopped it into 2 pieces and found the 2 different areas and added them together. Here's another one just like that, the next one, all right? Find the perimeter and area. Figure out what's missing. Looks like the bottom is missing here and the side over here is missing. Oh, let's see. Oh yeah, I could add 4 and 7 together and I'd figure out what this side was over here, right? Find the perimeter and area. And then we start getting tricky on you, huh? Find the area of the shaded region, meaning that whole thing. This is a combination of 2 different shapes. See the rectangle on the bottom. I got to use my rectangle formula. See the triangle on the top. See the base is going to be the same as this 11 for me, right? Find the area of the triangle, find the area of the rectangle, and add them together. Add them together. This one, even more steps, right? What's the area of the big circle? Okay, this is not necessarily obvious. Mine says this little circle has a 3 centimeter diameter. What you need to understand is that 3 centimeters, notice those 2 circles go from edge to edge. That 3, oops, get out of there. That 3 is the radius of the big circle. Does that make sense? Do that, put it in your notes right now, whatever. This big circle has this radius, which is the same as diameter of the little one, 3 for my problem. So you can use that to find the area of the big circle, pi times that radius of 3 squared. What's the area of both little circles? That means add them together. I wish it would be clearer. I always question that. So pi times the radius. I have to cut 3 in half is the radius of the little circle, right? Pi r squared for the little circle, and then times 2 to add them together. So what's the area of the blue section? Big circle minus the 2 little circles? That's why I'm talking through it, help you kind of analyze this problem. I've got to find these different pieces and then do something with them. Find the big circle, find the 2 little circles, and then subtract the little ones from the big one. Again, kind of visualize this one. A unicycle wheel, a single wheel, has a radius of 13.5 inches. If it travels in a straight line, the wheel turns exactly 17 revolutions. How far does the unicycle travel? What are they talking about? It rolled down the street 17 times exactly. Think if you can visualize, that's 17 times the circumference, the distance around that circle. All right, so use the information there. They gave you a radius. Use the information in the problem to figure out the circumference of the circle, the wheel. And my problem says 17 times that circumference will be the distance. So just roll, right? This next one's exactly the same kind of problem. Here's this rope or cord, cable coiled up. That number there, mine says 11, implies the diameter of one coil. You know, it's not exact when you coil it up, but we'll use a number. That's the diameter. So from that, you can figure out the circumference of one coil. And then mine says it's coiled 13 times. So 13 times whatever I come up with for the circumference of one coil. I've got a diameter to work with. If some of you hadn't already done this one, I probably would have removed it. I think this is the hardest question in this homework here. Part of it is mixed up units. How many rolls of wallpaper? So this really takes analyzing. What do I have to put together? This is maybe the surface area one I was talking about. You've got a room, right? And the room, first of all, you got to think about the room. Okay, I've got, say, 2 long sides and 2 short sides, imagining it's a rectangle, right? 10.9 feet by 16.9 feet. Okay, so there's the length and the width of that room, and then it's 10 feet high, right? So one wall would be 10.9 times 10 would be the area of one wall. And there's 2 of those, right? A rectangle, there's 2 of those. Then there's 16.9 times 10 would be the other side wall, and there's 2 of those to make the rectangle. So at least that's feet times feet, right? And so that would fit, and you add all those together, right? And you get the wall area of the room. And then it says, okay, now subtract 119. Mine says 119 for the doors and windows. So you figure out what's the surface area of your box, your room. Well, okay, now how many rolls of wallpaper? This is where they're mixing units. 9 yards. I'd change everything to feet, all right? A roll of wallpaper is 9 yards. How many feet is that? Well, maybe you know that one, 9 times 3. So for my problem, it's 27 feet long. And how wide is it? 18 inches. How many feet is that? And maybe your mental math tells you, oh, that's 1.5 feet. So the area of one wallpaper roll is 27 times 1.5 feet squared. So you got to figure out the area of one roll of wallpaper. Then divide your total surface area of your room by that number, right? How many rolls? It's kind of like if I was painting a room, you know, figure out your surface area, and a gallon of paint will cover 400 square feet. You got to divide by that 400 to figure out how many gallons. Well, that's what this is about. How many rolls? Like I said, this is kind of the messiest, the most different, the most steps, that problem.
So am I correct in understanding that there's just the homework on geometry? There's no textbook material other than the video lessons, correct?
That's right. This is not actually in your book, right?
Okay.
This is stuff we've added, reasons for you to do calculations.
Okay, thank you.
Yeah. Sorry. Let's see. This one's interesting. You know, you've got a rectangular field. If you double both dimensions, length and width, how much longer, how much bigger is the overall area? I might suggest that you sketch that, what it would look like, and see it to come up with your answer, if that's not obvious to you. Suitcase. Here. Let's see this. Notice again, 12. There's some mixed units. I have inches times feet times inches. What is the volume? Volume. Look at your formula sheet for a like shoebox shape, right? Rectangular solid. Volume is 3 dimensions, length times width times height. That formula will be there. But you need to get all the same units, right? And I wants the answer in feet, cubic feet. So you could change all those inches into, you'd have to convert into how many feet is 15 inches or how many feet is 4 inches. Then you could multiply them together to get your cubic feet. Round your answer to 4 decimal places. That's kind of odd, longer than usual. Just be real careful to go out all 4 places. Otherwise it'll mark it wrong for you. I might, notice that and give you a partial credit on a test problem or something, but see if you can calculate out the 4 places. Let's see, surface area. Oh, rectangular solid. Okay, so this is like the outside of a shoebox. What's the surface area? All 6 sides, right? All 6 sides, top, bottom, and 4 walls. 8 by 6 by 2. See if you can imagine or draw yourself a little cube or rectangular solid shape. But you're gonna find the surface area. It's 2 of this side and 2 of that side and 2 of the top and bottom. You can just add, you gotta get all 6 sides and add them together. Cylinder, there was that formula we looked at. Point was talking about that on the formula sheet. The cylinder has a radius, 6 feet, a height of 4, find the volume. So there's a volume formula for the volume of the cylinder. It's kind of like the area times how tall is it. That's kind of area of the circle times how tall, that's volume. Here's like one of those combinations. There's a cone shape, right, on top of a cylinder, and you're supposed to find the volume. I know it seems like it's getting more and more complicated, but push yourself. If you can figure out the shape and how to put the pieces together, you plug the numbers in the formula. Here you're told H is what, 7.4 in my problem, 7.4 feet. And the total height is 16.5. So gee, I gotta use this big one minus a little one to figure out how tall is the cone, right? I gotta figure out how tall is the cone so I can use the cone formula. So then you could figure out the volume of the cylinder and the volume of the cone, and you add them together. Pardon me. Excuse me. Oh, that is the last one. Good, because I want to mention, just time-wise, right? You're going to have a basic question or two, know how to do rectangles, triangles, and circles by test day, Thursday. This geometry homework is not due until Monday. Overall, all of it, right? Not due till Monday, just because here we are Tuesday this week. If you're managing your time, be able to do those 3 basic shapes and you'll be in good enough shape for our test. I hope that makes sense, right? Look at the perimeter and area of rectangles. Maybe even one of these weird ones, a triangle problem and a circle problem. What is that? Oh yeah, that's like the sprinkler problem. That's a circle area problem. So if you're comfortable or able to do those kinds of calculations for those 3 simpler shapes, put it that way, you're not going to run into this trickier stuff on your test, okay? I'll just tell you that to save your time for now. But do your best to work them through for homework due on Monday. Before I leave the sharing here, we're almost done for the day. Any questions about the sharing, the homework part, page that I'm showing. Otherwise, I'm going to stop sharing. We'll go back. Okay. All right, here we go. Yep, back to me. And, oh, I found my Math 20 textbook. Yeah, right. Math 20 text, a lot of this, many of you have said, oh, this is so far still review. If you were in Math 20, you know, well, you probably went over most of this chapter 1 material in Math 20. I've mentioned, oh, we got to cover all those bases in case you were in Math 20. Okay, so that's really what we're doing with the geometry section is finding the right formula, analyzing the shape, finding the different pieces I have to put together for area or perimeter or volume. Okay. So I guess I'm going to present about that today. I would encourage you to try a few of those problems, maybe before tomorrow, so that if you get stuck on something, we can show up tomorrow and ask some questions. All right. Get out of here in front of the camera. So change gears. How about questions from you? Things that you know, I got a couple minutes. I got some time today if you guys want to ask some kind of questions about homework or whatever. Anybody? Can we do one of?
I have a question.
Okay, good.
So for the ones that I have the most trouble with are the ones trying to find the shaded areas. Yeah, I don't even have an example to give. It's just like when they give you a shape and then there's like a shaded area for that shape, and they're trying to make you find like either the area.
Okay, so in your homework problems will look the same as my homework problems, although numbers vary. You know, everybody gets different numbers, right? What did we see there for shaded area kinds of problems, right? There was that one where the shaded area problems usually have to do with recognizing what are the different shapes that we're putting together. There was the one that looked like this. It was a rectangular, I made mine a little too square, but a rectangular shape and a triangle shape. So I have to find those two values separately, find those two areas separately. Use the area formula for the triangle, use the area formula for the rectangle, come up those two numbers and add them together. This one I mentioned is the sort of the tricky one where that was supposed to come all the way out here, right? Find eventually they want this area out here. So you had to find the big circle area. So this is like analyzing what to do before you actually do the math, right? I got to find the big area, and then I got to find these little areas, and I subtract those from the big area, and that tells me what's left here. That concept makes sense. I'm not sure who is it that was asking. Was it Gwen?
Yes.
Lynn? I'm not sure what else I can tell you, you know.
No, that actually helps. Yes, thank you.
Good, thank you. How about anybody else? It doesn't have to be a today question. It could be yesterday or anything that we've been covering. Are you okay? Or you want to give them a try? Send me the messages as usual during the day, and I'll get back to you. And tomorrow, you know, if you had a chance especially to work through some of every homework or even the review so that you find where you have trouble and you came to me with suggestions for things to practice tomorrow. That would be ideal. Okay. Anybody else before we let it go today?
I have something to ask after.
Okay.
Thank you.
No problem. All right, well, if that's good enough for them today, do your best and I'll see you tomorrow, all right?
Thank you very much.
All right, folks, take
See you
care.
tomorrow.
Yep,
Thank you.
you're very welcome, very welcome.
I'm going to stay after because I do have a question.
All right, no problem. All right, Kayleen, you want to get us started?
Sure. They're from various weeks, so I'm kind of ahead a little bit.
So if you're talking about chapter 2 stuff, I'm going to put you off and ask you maybe to send me that in a message and I'll get back to you. But if we haven't covered it yet, then that's usually I say, let's not take our time here for stuff I haven't covered yet. But I'll be glad to answer you.
What's her question first? And then
Yeah,
I'll ask.
right. Is that Gwen? You want to ask a question? Do you mind?
Yeah, yes, I'm sorry.
We should-
I
yeah.
I got a little confused on like the first question in the geometry homework. My question is find the perimeter and area of the rectangle cardboard measuring 10.6 centimeters by 17.3. So would I assume the 10.6 is the length?
It really doesn't matter, when we think of a rectangle, we usually think of length as longer than width, but it really is arbitrary. So draw yourself a sketch if you want. I would probably have called this width and called that length myself.
Okay, so in the math, it doesn't really matter.
Nah, no, and especially if you turn on an edge, you might call it height. It's like, oh wait, height instead of width or something,
Okay.
Yeah.
Okay, that's where I was getting stuck. Excuse
So
me.
perimeter will be 2 of those plus 2 of those.
Okay, right.
And
Okay.
area, you multiply them together.
Okay. Okay. That's okay. I was getting to
Overthink it or
exactly. Thank you. I overthink everything. Okay, perfect. Perfect. Thank you so much for explaining that.
You're welcome, Glenn. That's what we try to do.
And I know I'm struggling in the circles with the circles. That is something that I started yesterday and I went, oh.
So we've got those 2 different dimensions. We're trying to calculate a circumference, is like perimeter, or an area. So, use whichever formula, and you need to have either the diameter or a radius for one or for those 2. You gotta know which one's which, and and then and use pi.
I appreciate you sharing that today because it helped me understand it a little bit better. The only thing I'm struggling with is with my calculator with the pi and stuff, but I've been using the 3.14, so.
Yeah, that's accurate enough for what we're doing. That's good. It should be good enough for you. Yeah.
Thank you so much for sharing today because I needed that.
That's why I do this every day. That's why we have this, and it's not strictly an online class where you'd be doing it without instruction. Yeah, we're still trying to almost pretend I'm in the classroom teaching a Zoom lesson.
Right, right. I really appreciate everything you're doing. So thank you so much.
Okay, you're welcome, and we'll see you tomorrow, okay?
I'll see you tomorrow. Thank you.
All right, Keely, give it a shot. What are you working on? I'll do one, whatever. I'll do. Solving equations, is that what you're working on? Some equations?
I'm on week 2. The
Oh.
last question, number 4.
I'll just apologize. I misunderstood what you said. I thought you were working ahead.
I have 3 of them.
Okay, week 2, go for it.
The last question is, so it says, if the square in the center of the figure below has a side length of 4 inches, what is the total area of the figure below around your answer to the nearest tenth and include units in your answer?
Okay, I kind of didn't quite hear everything clearly. What's the shape?
That shape. Here, look at my screen.
Look at your screen.
Can you see it?
Where are you? I gotta find you. Oh, that thing. Oh, this was off the hand-in homework of which week was this? I mean, this must
2.
Week 2? Oh, that's right. That's why we put this off. Okay, that's right. Well, that's why I put off the week 2 homework. Okay, here we go. I get it. That's a good one. I'm surprised nobody else has asked me that one yet. So there's a square in the middle.
Yeah.
There's a square. So that's a certain special rectangle, but basically length times width, right?
So just 4 times 4 times 4 times 4?
If is this 4?
So it says the side lengths of 4 inches.
Okay, so Now, if you want perimeter, you add them up, but area is just 4 times 4, right?
Is that it? Just 4 times?
Width. Well, for the square, I mean, it's a rectangle, 4 times 4, length times width. Does that make sense?
Yeah.
You know, length times width. Now, that gets you the square in the middle.
Okay. Hmm.
This is half a circle with a diameter of 4.
Okay.
Right?
Then we do.
Can you? Is my drawing good enough for you?
Yeah, it's fine.
I did. It's a little.
It's good. It's okay.
There's half a circle,
Okay.
diameter 4.
Yeah.
Here's another half of a circle, the same diameter. I put them together, I got one whole circle.
Yeah.
And now here's 2 more. If I put them together, so basically I have 2 circles.
So I'm adding 4 plus 4 plus 4 plus 4?
We're doing area, right?
Yeah.
Pi r squared. And I have 2 circles if I put all those pieces together. Or, right, this is half, so I could do by area and cut it in half, but then times 4. This one and this one make a whole circle.
Yeah.
So pi r squared, what's the radius of that circle?
16?
Radius. This is the diameter, right? Goes like all the way across. Radius is half of that.
Oh, it's 2. Oh.
Oh, you overthought it. You went the wrong way. So pi times 2 squared happens to be a 4. That's where the 2's turn into 4's again anyway.
So the area for this one is 12.56.
Okay, that sounds like 12.56, whatever it is, inches squared is one of these circles. It's 2 of those pieces together, make one whole circle. But then I have these other 2. I don't know, maybe I'm confusing you by saying there's 2 circles worth here.
No, my brain's just confused. It's okay.
Otherwise, you could say one of those is half of this number, right? One of these pieces is half of that.
Then we just do the same thing to the other side?
And then I got 1, 2, 3, 4 times half of it. So I've got the, you want to figure out the square in the middle, and then I want 2 of these things. I'm going to add the square plus 2 of those full circles.
Okay, so can we complete it? So can we do?
So what is this? 4 times 4
is 16.
That's going to be 16 square inches.
Okay.
Right, so that's this part. And then I've got 1 pair is 12.56. So I need 2 of those. 2 times that is what, about 25?
25.12.
Okay. So 25.12 plus the 16. And make sure you say square inches. And how many decimal places the problem wants, maybe only 1. Oh.
Nearest 10th. So it's 41.12?
Yeah. Yeah.
Or 0.1?
Whatever the worksheet says to do for a number of decimal places. Does it tell you how many decimal places to use?
To the nearest 10th.
10th, 1 decimal place. 40.
Yeah.
41.1, huh?
Okay, that makes more sense. Okay, and then how much time do you have?
I got time today. I'm fine.
Okay.
Keep going.
Word problems make my brain go crazy. So this one isn't a word problem though. Gotta
leave yourself open to it because we're gonna keep coming back. I mean, I understand it's issues for everybody. Which one is that? The first one?
It.
Oh, 3x. Okay. 16 minus 5x. 3x is 16 minus 5. All right. This is the next chapter. I don't know why. Oh, that's right. We do some geometry in the end of next chapter. Or week 2? That couldn't have been week 2 hand-in homework.
It says week 2?
I better go look again. But
okay, and then
it's an evaluation. This is an evaluation. It's not solved, right? They tell you a number for x. Oh,
Is -8 a solution of the equation? 3x equals 16 minus 5x.
that's,
So that doesn't make, I didn't
so what, okay, time out, okay? Pardon me.
understand.
I'm gonna go, I'm really, I
Is
got,
anyone ahead or is it only me?
oh, okay. Excuse me. Hand in homework number 2, that first problem was on that hand in homework, but the one you're showing me now, whoops, wherever you went,
Is number 3.
it's not on the same worksheet.
No, it's on week 3.
Week 3, okay, there. I don't know if you saw my forum post yesterday. Lynn had asked about a certain question in the week 3 homework, and I realized we're behind schedule a little bit. So I actually have delayed that week 3 homework for another whole week. The hand-in homework for a week, all right? Because we're not ready for it. Obviously, you're asking me questions about stuff we haven't gone over yet. So just to set you at ease a little bit, you don't want to be spending too much time on that before our test, right? Make sure you're practicing, preparing for our test. But that hand-in homework will be after next week. You know, we have to go through next week's material.
What, can I still do it?
You can still do it. All right. So this is saying,
Oh, so x equals -8. Okay, that was my question. I didn't understand.
yes. So this is saying if I put in a -8, is it true? Put a -8 in for both the x's. And now, what is that? -24 and 16 minus is plus 40. Does -24 equal 56?
No.
No, no, those are not the same numbers. So -8 doesn't make this true. -8 is not a solution. It doesn't make this equation true. That's what you're,
Okay.
that's what you're being asked. Does this number solve it? Does it make it true?
Okay, and the next ones are confusing also.
You should put this aside and do your review for our first test, and let me present this next week, or ask me questions later.
Okay, and then I have one more and then I'll be done.
Okay.
The word question. I'll read it to you. Kayla's son came home from a school party with a bag full of candy. She counted 19 pieces of candy in all. There were twice as many Laffy Taffies than there were chocolate bars.
$19 pieces total.
Okay, and then there were 3 more Jolly Ranchers than chocolate bars.
Oh, Jolly Ranchers.
And Jolly Ranchers, yeah.
Okay, so 3 kinds of candy.
Mm-hmm.
This word problem is trying to get you to write an equation and then figure out how many pieces of candy.
Yep.
All right, let's say whatever, taffy, the amount of toffee, whatever it was, is twice the amount of chocolate.
Okay.
So notice these other 2, the toffees and the Jolly Ranchers, are described in terms of the chocolate. So we're going to write, if we wrote an equation that says 19 equals toffee plus chocolate plus Jolly Ranchers, we have nothing to figure out which one's more or the other, right? So here it's comparing them, so we can say, oh, I'm going to write one equation and all I have to do is write it in terms of the chocolate.
Okay.
Okay, so the toffee is twice the amount of chocolate, and the Jolly Ranchers is the chocolate 3 more than the chocolate. Did I get that right from what you said? Chocolate, there's 3 more.
Yeah.
Okay, so my 19 total is going to be the amount of chocolate, right? Plus the amount of toffee is twice the chocolate, plus the Jolly Ranchers is the chocolate plus 3. Now the C's in that one are like your X's. You can add them all together and you get 3 extras on the end. But you know, how many C's do I have? 1, 2, 3, 4. 4 chocolate plus 3. And now I'm going to solve that equation for the number of chocolate pieces.
And then I just do 19 divided by 3.
Oh, so here's where we don't, here's where the next week's lesson, right?
Okay.
This is added 3. What's the opposite of adding the 3?
Negative.
Subtracting the 3. So I want to subtract the 3 from both
Oh,
sides.
I got you. I remember how to do this now. Okay.
So now I've got 4 times the C is 16.
And the
How do I
C,
make it 1C?
C
What do
equals
I-
4. C equals 4.
Because you're going to divide by the 4, right?
Uh-huh.
There you go. Now, if they ask you the other ones, you got to go back and plug it in. Well, what's twice that is the toffee, and what's 3 more than that is the Jolly Ranchers. You know, how many of each kind of candy? You got to go back to your, you know, comparison statements.
Okay. How do I figure out how many? So
See, if chocolate's 4, well, twice that is toffee,
good Lord.
right? Does that make sense then?
Yeah.
And the Jolly Ranchers was 3 more than that, so 4 plus 3.
Okay.
And
Cool.
that should all add up to 19 if you were to check all those numbers again. Yes, I know. I do that too.
What hair?
Old guy hair too, it sticks out. Get my wings.
Yeah.
All right, hey,
Thank
good luck, work on that. You could send me some questions and I'll reply. But
I'll ask you tomorrow.
yeah, well, if you're ahead, if you're
Try
ahead,
not to
I
ask.
don't want to do it in class, right? I don't want to take class time if you're ahead. That's okay. All right, Kayleen, have a good day and I'll see you tomorrow.
You too.
All right, bye.